Good day, everyone. Today we're going to look at solving quadratics by using completion of the square. You'll recall that in the last lesson we used factoring to solve the quadratics. Completion of the square is just another method that will give you the same results if in fact the original quadratic was factorable. Okay, I should start by saying that this would be no one's first choice of methods. It's actually the most difficult of the methods to use, but it is important and sometimes its use is unavoidable. So let's get started. What we want to do when we use completion of the square is first move the constant to the other side of the equation. So when we do that, in this first example, we will have negative 12 on the right side of the equation. The next thing we do is we confirm that the leading coefficient is 1. Okay, so we have 1x squared as required for this method. And now what we do is we work out what I call the magic number. The magic number is simply the number that would have to be added to the left side of the equation such that it becomes a perfect square trinomial. And you might know what that is, some of you, but if you don't, this is how we work out what that number is. So essentially, you're going to take the coefficient of x, which happens to be negative 8. Okay, so let's work out that magic number over here. Take that coefficient of x, and what you do is you first divide it by 2, and after dividing it by 2, you're going to square it. Okay, when we divide negative 8 by 2, we're going to get negative 4. And when you square negative 4, of course, you're going to get positive 16. This means negative 4 times negative 4, so it's certainly positive 16. That's the magic number. It's the magic number because when we add it to the left side, that left side is now a perfect square trinomial. Now, we can't just arbitrarily add that number to the left side. We have to make sure we also add it to the right side like this. The right side now is simply going to be 4. On the left, as promised, we do indeed have the square of a binomial. This trinomial is the square of x minus 4. If you take x minus 4 and multiply it by x minus 4, you will get this trinomial back. Okay, in other words, this is the factored version of this trinomial. You can see that that's true. If we were going to factor this trinomial here, we'd say, oh, we want a product of 16 and a sum of negative 8, right? Product of 16 and a sum of negative 8. Both numbers, therefore, are negative 4. So the factors would be x minus 4 and x minus 4. In other words, x minus 4 all squared. A quick little tip for you is that inside the bracket here, along with x, will always be this number, the one obtained after you have divided by 2 and before you have squared. Okay, so that negative 4 is here. All right, so far we moved the constant, we added the magic number to both sides, and we wrote the trinomial in its factored form. Okay, now what we're trying to do here is solve for x. Let's not lose sight of what we're trying to do. In order to solve this now for x, the steps should be clear. What we need to do to begin with is to square root both sides. So in doing so, we're going to get this. X minus 4 is equal to the square root of 4, which is 2, but it is also negative 2. There are two answers. And so from here, we're going to get our two final x values. So we say x minus 4 is 2, and x minus 4 is also negative 2. From which, in this case, x will be 2 plus 4, or 6. And here, x will be negative 2 plus 4, which is 2. Okay, so in the last step, we simply add 4 to both sides because, again, we're trying to isolate x. All right, so that's using the method of completion of the square to solve this quadratic. Now, again, in this case, the original trinomial was factorable. The factors of this original trinomial are x minus 6 times x minus 2, from which these values could be obtained much more readily. But if you were told that you had to use completion of the square, this is how it would go. So first move the constant, add the magic number to both sides, factor the trinomial, it will always be a binomial squared, and then proceed to isolate x. In isolating x, there will be 2 steps, square rooting, and then moving the constant. Okay? Okay. We're going to try the very same thing with this second example. All right? So, step 1 was move the constant. So that would be the number here. Okay, you can see now positive 6 on the right side. And now is when we add the magic number. Now, it's a little harder to determine the magic number in this case, I think. But we'll do it the very same way we did it in example 1. We take the coefficient of x, which this time happens to be 5. Okay. And then that number is divided by 2 and then squared. Okay, now we could, see this is now not going to be an integer if we actually do 5 divided by 2, it's 2.5. And it's fine, we could proceed to use decimals, but I'm actually going to use fractions in my solution here. So you have the option of going to decimal here. If I'm going to use fractions, all I do is confirm that this can't be reduced. 5 halves can't be reduced. So then to square 5 halves, it's the same as squaring 5 and squaring 2 to get 25 over 4. Okay, alternately, if you're compelled to use your calculator in some way, you could do this. 5 divided by 2 is 2.5. Square that answer, and you can see I'm getting 6.25, which is the same as 25 quarters. So you can use 6.25 in the question if you like, or to change that number to a fraction, simply hit the fraction button here. This now says 6 1/4, but to make it an improper fraction, which this is, hit shift and hit that fraction button again. And now we have 25 quarters. Okay? In any case, 6.25 or 25 quarters is the magic number. So we go ahead and we add that now to both sides of the equation. Okay, so there it is, 25 quarters added to the left and to the right side. Remember what we did here now? We simply added -12 and 16 to get 4. So here I have to add 6 and 25 quarters. So if it was 6.25 plus 6, it would be 12.25. But if we want to work with fractions, we can make this 24 over 4 and add 25 over 4 to it. Or if we want to use the fraction button, we do this. 6 plus 25 over 4 equals. That's the answer as a mixed fraction. Push shift, hit the button again. And here is the result as an improper fraction. You can see that that's 49 over 4. Okay? Left side needs to be factored. It's a perfect square trinomial. It will always be a perfect square trinomial if we're using the correct magic number. We need to figure out what goes in here. It's going to be an x, certainly, and we have to figure out the rest of it. So, remember what we can do is we can say, if we were going to factor this, we'd say, oh, we want a product of 25 quarters. We want a sum of 5. What are those numbers? 5 halves and 5 halves. So we would get x plus 5 halves times x plus 5 halves. Okay, so we can think of it that way, or we can use the little shortcut that I talked to you about here. Remember, this number is -4, matching the number here, which was obtained after dividing by 2. Positive 5 halves is also the number obtained here after 5 was divided by 2. So it's this number here before squaring. Okay, so that's the little shortcut, but this is the explanation behind it. Okay, now that we've got it in this form, our next steps are just to isolate x. This will require 2 steps. First, we're going to have to eliminate the square and then move the constant. So let's eliminate the square first. Now, when we eliminate the square on the left side, we are actually taking the square root. So we have to also take the square root of 49 over 4. And that's going to be the square root of 49 over the square root of 4. Okay, so we're going to get 7 halves. And of course, we have to remember that the square of -7 halves is also 49 quarters. Before, I had 49 quarters on my calculator screen still. So if I was using my calculator for all of the fractional computations, I could just push square root now. That's the mixed fraction. And there it is. That's also the 7 halves improper fraction here. Okay, now that we have this, we break it into the 2 possibilities using positive 7 halves on the right side and negative 7 halves on the right side. How do we isolate x? We have to subtract 5 halves now from each side. So 7 halves minus 5 halves, and also negative 7 halves minus 5 halves. 7 halves minus 5 halves is 2 halves, or 1. And here, negative 7 halves minus 5 halves is negative 12 halves, or negative 6. So we've obtained our answers that way. And again, you can do all of those calculations here. So for example, if I wanted to do 7 halves minus 5 halves, the 7 halves is on my screen here, so I can do minus 5 halves to get the answer of 1, and so on. So you can do all of the fractional calculations in the calculator if you like. So I hope that those 2 examples were okay. We're going to do a couple more together because this topic is not easy. So let's try example 3. Move that over here. Okay, in trying this 3rd example, we should notice that the terms are not in the right sides. So we're supposed to have the constant on the right. So this one on the right. This one should be on the left. So we have to start by rearranging that, okay? So for completion of the square, it's the constant that's supposed to be on the right side. Okay, so we begin by making that the case. So that means subtracting 12x, like this, and also subtracting 9 like this. So now it's the correct form. However, completion of the square also requires us to have a leading coefficient of 1, and we had that in the last two examples. We don't have that here. So we have to, before calculating that magic number, we have to divide all of these terms by 4. So that's going to give me x squared minus 3x equals -9 quarters. Okay, so we start by dividing all the terms by 4. And again, I'm going to leave this as a fraction, but if you hate that, you can make that a decimal number. So -9 divided by 4, right? You could use this as your result instead on the right. Okay, now we're ready to do the magic number calculation. So I take the coefficient of x, which is -3. Make sure you take the sign with it, right? So we have to take -3 and do two things with it. We need to divide it by 2, and then we need to square it. This fraction cannot be reduced, so we just square -3/2, which means squaring -3 for the numerator, and that's +9, and squaring 2 for the denominator, and that's going to give you 4. Again, you could do it with your calculator. -3/2. Put that in your calculator first. Square it. Right? So there it is, 9 quarters. I should point out, if your fraction button is not working, it probably means you have engineering mode on. Engineering mode must be off if you want to have all the features of the fraction buttons working. So turn that engineering mode off, please. One more thing, when you're squaring a negative number, it's always going to be positive. But some students get confused because if you do this, -3 squared in your calculator, you see, it says -9. You have to put it in a bracket, -3 squared, like that, +9. Okay, anyway, so we put it in the correct order. We made sure the leading coefficient was 1, and now we've computed the magic number. The magic number must be added to both the left side and the right side. So +9 quarters is added to both sides of the equation. The left side will now be the square of a binomial. On the right side, we simply do the adding required. This time though, look, when we add these numbers, we get 0. So that's a little bit different. Okay, we have to figure out what binomial goes in here. Certainly, there will be an x here. We need to know the number that goes here. Remember that it will be the coefficient of x after dividing by 2. So it will be -3/2. Okay, the coefficient after dividing by 2 and before squaring. Okay, but to confirm that, you could say, all right, here's a trinomial. I want a product of 9 quarters. I want a sum of -3. Would that be obtained if I use the numbers -3/2 and -3/2? Yes, it would. If I multiply these together, I'll get 9 quarters. If I add these two numbers together, I will get -3. Okay? All right, so in order to solve for x, we would do two things. First, we would square root both sides. This is where normally we'd have two answers on the right. We would have the positive and the negative answer. However, when you square root 0, it simply remains 0. Next, we isolate x. So in this case, add 3/2 to both sides of the equation. We have only one answer in this case. It is x equals 3/2. Okay, so one answer obtained because the sum on the right side was 0. All right, we're gonna do one last problem together. It's here. 10x squared plus 13x minus 3 is equal to 0. So let's go ahead and do that. Our first job is to move the constant. Our second job is to ensure a leading coefficient of 1. That means dividing all terms by 10. So 13 over 10x and 3 over 10. It's time to calculate the magic number. So we begin by taking the coefficient of x. 13/10 is the coefficient of x. We need to divide that number by 2, and then we need to square that. Okay. Let's first divide that number by 2. 13/10 divided by 2 is actually 13/20. You can certainly do that with your calculator. 13 over 10 divided by 2 is 13 over 20. Okay, now I have to square that. That's going to be the same as 13 squared, or 169 over 20 squared, which is 400. Or we can just do squared here, squared. 169 over 400. That's the magic number. It's going to be added next to both sides of the equation. Okay? Now, add the numbers on the right. To add these, of course, we would need a common denominator. So we would need to change 3/10 such that it has a denominator of 400. Or we can cheat and use the functionality of the calculator. So 3/10 plus 169 over 400. 3/10 plus 169 over 400 is, and you can see what we're getting there, 289 over 400. Okay, so again, you could either first make this have a denominator of 400, which would be, I guess, making it 120 over 400 in order to add them, or you could just cheat and use the calculator. I say cheat, but using your calculator in no way is actually cheating, okay? This is an approved calculator for the course. Use it in any way that you like. Okay, so now in here is a binomial whose square is equal to this trinomial. We know there will always be an x at the start. We simply need to determine the number here. Remember, it will be after we divided this coefficient by 2. So here's 13/10 divided by 2. What did we get? 13/20. So this will be positive 13/20. Okay, if you want to confirm that that's correct, you can go through the process of saying, okay, if the product is 169 over 400, and if the sum is 13/10, would the numbers 13/20 and 13/20 work? And yes, they would. Multiply these fractions, you'll get this number. Add these fractions, you'll get this number. Okay, so we've got it in its factored form. The next step is to square root both sides. And all that does in the left side is eliminates the square here. We need to take the square root of 289 over 400. The number's already here in the calculator. I might as well just hit square root equals, okay? So we get 17 over 20, which of course is the square root of 289, 17, over top of the square root of 420. Don't forget the two options. Split this now. One side positive 17 over 20. And in this case, negative 17 over 20. In isolating x, we will be subtracting 13 over 20. Okay, so what do we get here? We get 4 over 20, which is the same as 1/5. And here we're going to get negative 30 over 20, which is the same as negative 3/2. All right, so please take the time that you need to learn how to solve quadratics using completion of the square. You certainly will be tested on this particular method. You'll have to use this method on your module test. So take some time reviewing these 4 examples again, and then I'm going to direct you to try questions from your textbooks. I'm going to get you to try 11, 13, 17, 19, and 20 from the appropriate exercise. Okay, but I will post those problem references in Blackboard. So check the item in the Module 4 folder right where you found this video link, and I will have those questions listed as well as the chapter reference from the textbook. Okay, thanks a lot, guys. I hope you have a good day, and another video will be coming shortly. Thanks.